Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This is number 2936, number of equal numbers blocks. So basically the question itself is not too hard to understand. Basically you just want to return the length of a set of nums if this was a set. So for how many unique numbers are nums, just return that. So the trick here, because we can do this in multiple ways. So the easiest way is just to create a set and starts I at 0. And let's just say for I in range to nums.size, right? Because that's going to be the API we need to use. And then we just want to add nums.at_i. And then we can return the length of scene. But obviously this is a bit slow because it's a linear time solution and there's a better way to do it. And I'll show you the way that I came up with to overcome this. And as you can see, it's taken a long time. Okay, time limit exceeded. Cool. So what I did instead was, if you notice, these are chunks. So basically, why don't we use a binary search? Let's start left at 0. We're still going to scan the array, but as long as the current element is the same, we're going to track the index. Because, for example, we can go here now, and then we can just jump here because that's the next one that's different. And we just keep trying to find the rightmost index to the right of the current pointer that is the same element, because everything in between is going to be the same. So yeah, that's basically the idea. And now we can just say while left is less than nums.size, and now we can start the binary search, which is just going to be left nums.size -1 while left is less than or equal to right. We're trying to find the farthest index to the right, the farthest one away from the current index to the right that is still the same value. So let's say mid is left plus right divided by 2. So if nums.at_mid is equal to our current value, let's call this value is going to be nums.at_l. So if it still is, then we can just say the big index, because we're going to track everything to the right. So big is max of big and mid, and left equals mid plus 1, because if it's still the same, let's just keep going. And basically we already know that everything before that is the same, so let's shrink the search space by throwing away the left half. Okay, otherwise we have to shrink the right half, and at the end we're going to say max of L plus 1, because at least we want to make progress, and then big plus 1, right? Because big plus 1 is going to be this in this case, then we have to jump to the very next one. And in the worst case, if big still is the same thing, then we're going to just go here. Okay, and at the end we can just return answer, and answer is just going to be how many of these iterations we have, right? Because these are chunks again. Okay, so let's run this. Okay, so it looks like let's see what's going on. Okay, so time limit exceeded. Okay, so yeah, so if it's at the value, then it's still going to be the same thing. And oh, that's the problem. So left and right are not the same thing as L and R. This is going to be the pointer. So let's run this. Submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video. Thank you for watching and stay tuned for more.